Welcome back to AI Weekly News by Cyber Intel Systems. I'm glad you're with us. I'm your host, Lisa Parsons. Today's story is about science. One builds chain of evidence into autonomous research. Chain of evidence has two requirements. Completeness means each claim carries a recorded path to a source, such as a retrieved paper, a program, an experiment log, or a result table. Correctness means the linked evidence genuinely supports the wording of the claim, the science. One framing has three main parts. A problem investigator retrieves up to 100 full-text PDFs per topic through the Semantic Scholar API and build a structured research brief. References in the final paper must come from that retrieval process rather than from the model's memory. Discovery engine explores candidate solutions in parallel branches. Sealer agents implement ideas, evaluators score them, and promising branches are refined. Raw outputs remain in a read-only record that connects each final score to its run. The writing stage does not simply summarize whatever the agent remembers. A paper writer creates a structured representation of factual claims and attaches evidence tags to workspace artifacts. A separate claim verifier checks each statement and restates claims conservatively when their wording goes beyond the available support. The researchers also built a post-hoc CUI audit that can evaluate other systems. Met it independently. Rerun submitted. Code to verify reported scores, checks whether a solution violates the task specification, validate to be let a key, mentation. The final comparison uses language model judges for method code alignment so that check is useful, but not an infallible human review. The authors applied the audit to 75 papers across 5 autonomous systems and 5 tasks from the FIATA design of research systems benchmark. Baseline systems reached phantom reference rates as high as 21%. ScientistOne recorded 0 phantom references among 337 citations, passed score verification on all 12 papers, tested for that measure, and passed method code alignments. The performance results are also notable, although they remain author-reported. ScientistOne matched or exceeded human experts on all 5 benchmark tasks and achieved the best overall score on Cloudcast and EPLB. The claim is about those defined automation tasks, not human-level scientific judgment across medicine, physics, or every research discipline. Let's pause here for a short break. We'll be right back after this bumper. Welcome back. If you find this useful, follow and subscribe to AI Weekly News. Now, let's continue the news. The team also tested 5 Mel bench competitions and PABIMOT. Golf. It reports 2 gold and 2 silver medals on Melly bench, including a winning 3-dimensional object. Detection result, where compared baselines failed. It's valid PABIMON. Golf. Submission held a state-of-the-art score as of the 27th of April, 2026. For research organizations, the larger opportunity is an audible FROP rather than another headline benchmark. Evidence tags, immutable experiment records, reproducible runs, and conservative claim writing could make machine-generated work easier to inspect. Those practices may also help human teams manage experiments whose code, data, and prose drift apart over time. The strongest reported result is not that the system never hallucinates. It is that none of the 337 references in this particular evaluation were phantom citations. That architecture sharply reduces one failure mode. But it does not prove that every retrieved paper is reliable, relevant, correctly interpreted, or complete. Reproducibility also depends on the environments. PAPs change, datains move, training runs vary, and private artifacts may be unavailable. A trustworthy implementation still needs version dependencies, data provenance, retained logs, and access controls. The paper is an ArcSiv preprint, and its public results come from the authors, and Google independent teams still need to reproduce them, test other domains, and measure the cost of evidence chains at scale. ScientistOne offers a useful change in emphasis for autonomous research. Instead of asking only whether an agent can produce a strong answer, it asks whether another person can trace the answer, rerun the work, and see where each claim came from. That is a better standard for science than fluency alone. Watch for independent replication, broader domain tests, and open tooling that lets researchers audit systems they did not build. If chain of evidence survives those tests, its most important contribution may be a simple rule for AI-generated science. No claim should travel farther than its evidence. Thank you for listening to AI Weekly News by Cyber Intel Systems. Subscribe and join us next week for the latest AI stories.